Hello, our beloved and honorable teacher. So right now we want to present it about our research result, which we are researching about the effect of ethanol extraction of bark on phenol liquefied wood residue, which was proposed by me, Jody Saputra and my friend, who Alfando J.H. Without our advisor is Mr. Amenugroho, replaced by Mr. Suherman. So for the outline of our presentation, we will firstly explain about the background and then about the preliminary research and continue to research objectives and then research methodology and then results and discussion, and then in the end is the conclusion. So firstly, we are going to talk about the background. Wood bark has been regarded as one of the renewable promising material from lumber waste. Bark is known to be rich in one component, which is extractive, such as antioxidant, terpenoids, polyphenol, and other things, and can be recovered through the extraction, such as ethanol benzene extraction. But the waste that was resulted from the ethanol extraction, which was mostly composed of lignocellulosic material, are not really used very well. So in this research, we are going to utilize the extraction residue, which was the extracted wood bark, to be processed as the raw material for phenolic resin through the phenol liquefaction.
So next, this is the preliminary research, and the first research is from Hassan Kim and Wan, 2009, investigated the liquefaction of salt pine wood result for resin, and second, Wang et al., 2010, used the phenol and sulfuric acid as a catalyst on Japanese cedar. The result is there are more free phenol will be residues after liquefaction compared to when using sulfuric phosphate as catalyst. And the third is from Alma and Bastruk, 2006, using grapevine cane to prepare result type PF adhesive and applying it on wood, then investigating the adhesive properties. So this is the research objectives. The first one is investigating the effect of ethanol extraction towards the wood chemical composition. And second, investigating the effect of ethanol extraction towards the conversion of liquefied wood. Third, investigating the effect of chemical composition on liquefaction efficiency of four different kinds of wood. Okay, so this is the research methodology can be presented by Jody.
So firstly, about the research methodology, we are going to talk about the research design. So in the research design, firstly, we are preparing the material by milling the bark powder into the particulate size, which was under 120 mesh. And then we are going to analyze the content inside the bark powder, such as the ash content, ethanol benzene extractives, hollow cellulose content, and also the glycol content. And then next, we are going to extract the bark powder, which was prepared before, with the ethanol benzene extraction to extract the extractives. And after we are extracting it, we are going to analyze its content by the same as the previous material, the ash, and then also the ethanol benzene extractives, and the hollow cellulose, and also the glycol lignin. And then next, from both of the material which was prepared, which was extracted and non-extracted wood bark, are liquefied under phenolysis. And so after the phenolysis, the product will compose of two main phase, which was the liquid phase and also the solid phase. We are going to separate it. The solid phase is called as a residue. So for the residue, we are going to try it, and then we are going to analyze its content, which was ash content, ethanol benzene extractives, hollow cellulose content, and also the glycol lignin content. Next. And so for the materials, actually, we are going to use four different kind of variable. Three of it was the a wood bark, and one of it is the wood. So for the wood bark, we are having the Cryptomeria japonica, and then old Acacia confusa, new Acacia confusa, and for the wood variable, we are having the sawdust. And then for the other material, we have water, methanol, ethanol, toluene, phenol, sulfuric acid, acetic acid, and sodium chloride.
So this is the research variable. We have two variable which are independent and dependent variable. The first is independent variable. Wood bark species, there are Japanese cedar, old Taiwan acacia, new Taiwan acacia, and sawdust. And second, bark pretreatment, non-treated wood bark and ethanol extracted wood barks. So this is the dependent variable. First is S content, and second holocellulose content, the third collection lignin content, fourth extractive content, and five liquefaction efficiency. Okay, so this is the result and discussion. The first is effect of ethanol extraction on chemical composition of bark. This is for before ethanol extraction, and this is the effect of ethanol extraction on chemical composition of bark after ethanol extraction. From the figure, we can see that each wood bark has different composition in holocellulose, collection lignin, extractives, and ashes. First, the differences of composition in wood bark and wood can be compared from sawdust compared to the other wood bark. Sawdust, which is wood, has higher composition than wood bark, but lower in extractives, ash, and collection lignin, among other variables. Different kind of wood bark also shows different composition. Japanese cedar, which is soft wood compared to acacia, has lower extractives and ash amount. Meanwhile, the effect of ethanol extraction can be seen from the significant decrease of extractives, yet the amount of extractives extracted might be different due to some extractives are insoluble in ethanol benzene solvent and remains inside the wood barks. Okay, next.
So the effect of ethanol extraction on residue formation. So the liquefaction of bark after ethanol extraction form a lower amount of residue rather than the residue that was formed from the bark that are not extracted with ethanol. And the pretreatment using ethanol extraction caused remarkable decrease on the total residue of liquefied bark. The decreasing amount of residue might be caused due to the decreasing amount of extractives. It is known by some literature that extractives may hinder the decomposition of the wood bark of the lignocellulosic material, and also furthermore the amount of extractives decrease the thermal stability of wood, such as tannins and then gums, starches, and promotes the tar formation during thermal degradation. And then next is we're going to discuss about the effect of ethanol extraction to bark component conversion, which is holocellulose and also the lignin. So the conversion of in phenolysis, the conversion that happens occurs on holocellulose and also the collection lignin. The conversion of holocellulose is higher than the collection lignin in Taiwan acacia bark and sawdust. Meanwhile, the collection lignin conversion is higher than the holocellulose in Japanese cedar. So in the figure, the effect of ethanol extraction observed on holocellulose and lignin liquefaction ratio. The holocellulose liquefaction ratio decreased in Japanese cedar, Taiwan acacia, and sawdust, while it is increasing in new acacia. The collection lignin liquefaction ratio increased in old Taiwan acacia, new Taiwan acacia, and sawdust, while it is decreasing in Japanese cedar. So during the liquefaction of lignocellulosic material, cellulose is the least easy component to be liquefied, and then followed by the lignin and also the hemicellulose. So the lignin is the lignin and hemicellulose is the most easiest material to be liquefied. And the holocellulose conversion of wood bark is higher than glass and lignin, may be attributed to the constituent of sawdust, which contains more hemicellulose and react more easily to the phenolysis. And then, well, maybe the glass and lignin in Taiwan acacia and sawdust are harder to be liquefied due to the difference of lignin structure between two species. So there are a lot of kind of lignin. So like mostly it was composed of guaiacil and also syringil, and both of the kind of the lignin has a different kind of stability, has different kind of reactivity, and so it causes the different results in the liquefaction ratio of gas and lignin.
Okay, thank you. So this is the conclusion of our research. There are three conclusions. For the first is ethanol extraction has significant effect on reducing the extractive amount by ethanol benzene extraction. Constant amount of holocellulose observed on Japanese cedar, increasing amount observed on Taiwan acacia, and decreasing amount observed on sawdust. Meanwhile, after the ethanol extraction, the Clarkson lignin content increased. The second, ethanol extraction on bark remarkably decreasing the residue amount in phenol liquefaction. The third, liquefaction ratio of holocellulose and lignin on barks are different to each other, whether it is before or after ethanol extraction. This might be occurred because of the different composition in holocellulose and different structure of lignin. Okay, so this is the suggestion for our research. Further analysis is needed on solid residues such as surface analysis of SAM, FTIR, and NMR functional groups. Okay, so this is for our presentation. Thank you for your attention. Good day.